Uh-oh. For the last time in Physics 11. For the last time in Physics 11.
No.
Boy, you... Matt, you were away for a couple of days. They figured out the little dance we're doing. Hey, Matt, what's part A asking me to find? So, work. My first thought would be force times distance. Raises is a synonym for lifts. You know what? We thought about this for a while, and we said it's just MGH, and in fact, it's the change in potential energy. So it's going to be 688 times 9.8 times 2.4. I'm not using the 45 yet. 688 times 9.8 times 2.4. Did you get 16,000? I'm going to go 16,200 joules. Is that correct?
Yeah.
If I was counting this one for marks, I won't be this time, but if I was, I would say all or nothing. Little one marker plug and chug. What does B want me to find? Power. Well, power is work over time. It's also force times speed, but I'm pretty sure I'm going to use this first version. In fact, I think it's going to be my answer button divided by how many seconds? 45. 360? 359.6, but 360. And power is measured in watts. All or nothing. This question here, number 2, caused much discussion. So, why is the answer 0 joules? Yes? Okay. If you're carrying something, that would be the direction of your distance. But what direction is the force acting on the object that you're carrying? Good old mg, the obvious one. Are the force and the distance in the same direction? No. I would have done a piggyback demonstration, I'm sure. And the point that I was saying was this. You do work on an object. So whoever was piggybacking someone, once they hit a constant speed, was their kinetic energy changing once they hit a constant speed? No. Was the person's potential energy changing at all? Not once you had them on your back. So from the work energy theorem, change in potential plus change in kinetic, you had no change in potential, you had no change in kinetic. It's 0. However, someone, and I may have already done this speech, I did it in one class yesterday, but I didn't do it in all 3. Someone asked me, okay, Mr. Duke, how come if I'm just holding something heavy, I get tired? Doesn't that mean I'm somehow using energy? It is true. So I fibbed a bit. You're not doing any work on the object, but while you're standing just carrying something, muscles in your body are expanding, contracting, microscopic muscles, but they are in the same direction as the force. That distance is in the same direction as the force. And that's why even just standing, you will eventually get tired, or holding on to something, you will get tired faster. You are technically burning energy, but you're not doing work on the object. You're not making it gain any energy itself once you've got it in position. Is that okay? I'm being really nitpicky, Ty. I know. Yeah, we're used to that. Shut up. Okay, fair enough. I hear you. How much force? This was a bit different. First thing I did was, Tyler, I said, nice try, 65,000 watts. I also saw the word lifts, but then I thought, I'm not so sure I'm going to need that. First thing I noticed is they gave me power, and so I said, okay, power is work over time. But that's not what they wanted. They wanted the force. Wait a minute. How can I write work in terms of force? Work is what times what? The next thing I said was power. I guess that means it's force times distance over time. Aha! I said. Gerard, how would I get the F by itself? How will I move the D over? How to move the T over. Now, I had a few people do this in steps. So I had some people, they said, I just found the work by timesing by T. And then once I found the work, I divided by D. You know me, if I can do it in one step, yeah. So you're telling me, and I think I agree with you, Gerard, the force, yet another way to find force, is power times time divided by distance. I think that's our fifth or sixth way we've seen to find force, and there's probably a bunch more. Power is 65,000 watts. Checking the units as I go. Time is 35. Distance is 17.5. So I didn't need to use the MGH here. It's going to be 65,000 times 35 divided by, I think this will work out evenly. 130,000, is that right?
Yeah.
And this is force, so newtons. If you got that right, 2 out of 2. Otherwise, I would probably give you a half mark if I saw that, a half mark for that, a half mark for the numbers, and a half mark for the answer. And if you did it in separate steps, but you got 2 out of 2, Josh, I'm fine with that. But I'll try and nudge you towards organized laziness. I think it's a good place to get to. Number 4, A says find the kinetic energy of the bullet. Well, kinetic energy, that's not going to change. It's going to be a half mv squared. Although I said, nice try, Mr. Dewick. 4.2 grams is 0.0042 kilograms. So it's going to be 0.5 times 0.0042. 965 meters per second. That's very fast for a bullet. That's about 3 times the speed of sound. In fact, I would tell you this is a high-powered rifle. This is a very high-powered rifle. Oh, by the way, here's what else that means. One of the many ways that movies lie to you. You've all seen, probably watched a scene where you hear the sound of the rifle and then a bullet hits nearby. Is that possible here? No. The bullet would hit, and if you were lucky, you would notice and see the puff of dust somewhere. Only then would you hear it, because they're going faster than sound. But that's nowhere near as dramatic, so they do it the other way around. You mean movies lie to me? Yeah, and wrestling is fake too. Sorry. I know. Boy, hitting the wrong button here. 0.5 times 0.042 times 965 squared. Do you get, I'm going to write 1960. 1,900. I'll keep this on my calculator. But 1960? Somebody, I think it might even have been in this class, made a good argument for part B. They said, Mr. Dewick, I'm not sure what you mean. I think some people thought maybe we were firing it upwards instead of horizontally. So what I've done next year in this quiz, after the meters per second, I added the word horizontally so that we're firing the rifle this way. That means it's over level ground. That means there's no change in potential. Because this did ask how much work. My first thought would be force times distance. Did they give me a force? Did they give me a distance? No. My next thought would be it's the area under a force versus distance graph. Be obvious. Did they give me a graph? No. Gibson, my final pivot might be, hey, maybe it's the work energy theorem. Change in potential plus change in kinetic. And Oliver, I can say that because it's horizontally, but you're right. The question was vague, so I've added that. And you know what? I know the change in kinetic energy because what's change in anything, boys and girls? So it's going to be a half mv final squared minus a half mv initial squared. Although I wasted time, didn't I? I might have noticed, hey, from rest, I could have just done that. In which case, I know the answer. It's the same answer as before. It's the same answer as part A. So the bullet picked up kinetic energy. How? Work was done. What did the work? The gunpowder. The gunpowder. Part C says if the work is done over a distance of that, what's the average force? I could probably find this. In fact, I know I could find this by going F equals what? But what did I find in part B? Work, you say? You know what? I would go straight to force equals work over distance. I would look at my green sheet. W equals F times D, and I can get the F by itself. It's going to be my answer button divided by 0.0, no, not 0.0, Mr. Duke, 0.75. This is how also I knew it was a rifle, because 0.75 meters is about like that. Is that how long a pistol barrel is? No, this is a rifle. Okay. Do you get 2,610 newtons? All or nothing. Sorry, what was that? Pi times pi, why does it equal 9.8? It doesn't quite equal 9.8. It might be close. Yeah. I'll give you some basic questions. I think, and I have to double check, I think we still don't know if that number is rational or irrational. You'll get a numerical answer on your calculator, but we're not sure whether it's one that goes on forever without repeating or whether it's an actual rational number. Can you write that cleverly as a fraction? I think that one, YouTube comments are going to flood me because I may be misremembering. I know there's some version of pi to pi, or maybe pi to something else, where, I don't know. We could suspect, we don't have a proof, right? Just because it goes on for 1,000 digits doesn't mean that suddenly it doesn't start repeating. We've had some situations in math where, oh, that pattern lasted for the first 9,000 options, but turns out the 9,001st, the pattern didn't hold, so actually it wasn't a proof, right? Yes?
3x plus 1.
Pardon me?
3x plus
3x plus 1? Yes, that's also one as well. Another basic one, let me pause the video for those of you on YouTube. Potential energy, MGH. It's going to be M50 G 9.8. Instead of writing 4 times 10 to the 2, Oliver, I de-scientific notation did because 400 is quicker to write. That is one of the reasons it's helpful if you can do scientific notation in your head. I should be able to do this in my head, by the way. Is it 19,600 or 196,000? I know it's 196 something. Okay. B, what's the change in potential energy? Hey, what's change in anything? So the delta PE is going to be PE final minus PE initial. It's going to be, I guess the final is going to be 50 times 9.8 times 200. The initial is 196,000. You're going to get a negative answer. Yep. And that's okay in this. In fact, you're going to end up getting a half of that because 200 is half the height. So is it 98,000? Yes? No? What's the negative telling me? This object lost energy because it lost potential energy. Doesn't mean it lost energy. In fact, it didn't lose any energy because the law of conservation of energy says it was conserved. Oh, it gained kinetic. It sped up by that many joules of kinetic energy. And if I knew more information, I could probably even figure out the speed. Kinetic energy of the bike and rider. Okay, KE equals a half mv squared. It's going to be 0.5 times 85 times 8.5. Don't forget the squared. You get 3,071? I'll go 3,070. Is that right? Okay. Joules. The rider coasts up the hill. Assuming there is no friction, at what height will the bike come to a stop? Is there a change in height, Matt? Caught you looking at your phone? Don't be looking at your phone. Was it a calculator? I apologize. Folks, is there a change in height? Is there a change in speed? Is there a yucky curvy? Is there a change in height? Hill? Yes. Is there going to be a change in speed as you coast up the hill? Yes. Is there a yucky curvy path up the hill, Gibson? Is there a yucky curvy path up the hill? Yes. So Gibson, you know what this is a good job for? The law of what? Yeah, except I'm going to take some shortcuts. I would start with this. But then I would say, you know what? I know I'm coming to a stop, and I know I'm starting on the ground. In fact, I might even have started with that. I might have done the crossing outs in my head and jumped straight to it's 3070 equals MGH. Final. Gibson, redeem yourself. How to get the H by itself? Remember how weird that was at the beginning of the year? I'm hoping most of you are at the boring casual stage with that. If you are, it sounds sad, but I've done my job. That was my goal. I can do this in my sleep. And I would be fine with that for your work. The final height is going to be answer button divided by bracket 85 times 9.8. It was massive 85, right? Did you get 3.69 if I round up properly? 3.7 meters. Last two. Suppose an object is traveling at 10 meters per second. What happens to its kinetic energy if we double its speed? Sorry? That's the only way you can answer that. I didn't give you enough information to calculate it, although you could have made up numbers. Why is it 4 times larger and not 2 times larger? What if we tripled the speed? Okay? And again, I've tried to give you the encouragement, drive a little slower. Yes? Sorry? What happens if it's square roots? No, it's squares. Yes. It's square roots. Then what you'd be saying, if we double its velocity, you'd be saying it's the square root of 2. It's only 1.41 times as big. If you hadn't put the word roots there, I would give you credit for that. But roots means this operation. No. It's the exponent operation, the squared. Okay? Is that all right? This last one is going to be conservation of energy. Well, first of all, for part A, it says neglecting friction, how much kinetic energy? I could do a full conservation of energy, but I think the kinetic energy is going to be the initial potential is going to turn into kinetic final. So I'm just going to crunch this really, really quickly. The final kinetic energy is going to be MGH. It's going to be 3.5 times 9.8 times 2.3. The final kinetic energy is going to be 3.5 times 9.8 times 7 point something? 78.9, 78.89. I'll write 78.9 and just store that on my calculator. Joules. Then B asks, okay, what will its speed be? Well, I'm going to be bold and get the V by itself just by looking at my green sheet. I think the V is going to be 2 times the kinetic energy divided by the mass. And, that's a square root. It's going to be 2 times my answer button, 78.89, I think it was, divided by 3.5. It's going to be 2 times my answer button divided by 3.5. Square root of that. It's going to be 6 point something. 6.71? Units, meters per second. This was worth 3 marks. Each of these would be worth 1.5. I would give you a half mark if I saw that, half mark for the numbers, half mark for the answers, half mark if I saw that, half mark for the numbers, half mark for the answers. But if you got them right, you get 3 out of 3. Can you give yourself a lovely score, please, out of 16?